Hey everyone, geophysicist Stefan Burns here. We are right now in a geomagnetic storm. It's been going on for about 24 hours now, and it does not look like it's going to be ending anytime soon. This is a long duration geomagnetic storm. It's because of primarily this coronal hole here. We also see this coronal hole here though, slicing through the equatorial plane of the sun. And this is an area that emits a high-speed stream of ions. The plasma temperature is lower, it's just darker in color, so you see it very clearly. And this high-speed stream is sweeping by the Earth right now. This is that second solar shockwave that I talked about. We're in it right now, and we just hit a G1 level after a long ramping up period to those conditions. You'll notice a whole bunch of activity behind the sun. We're going to have to deal with that over the next week or so. We have a whole, look how bright it is. So that is something for you to think about for the next week or two. Just FYI, if you're watching this video, I will be on vacation for the next week in Jamaica, so I will not be releasing as many updates. But this solar wind stream that's sweeping by the Earth right now, that's being absorbed by the Earth in massive amounts because of the conditions right now that exist with Earth's tilt axis and its orientation to the Sun-Earth direction and the Russell-McLaren effect and a whole bunch more. This is causing the Earth to basically rapidly electrify. And this is something that has happened before. It kind of depends on your use of the terminology. But anytime you get this sort of influence from the solar wind or a solar storm, you get a whole bunch of mass from the sun and energy and information deposited into the Earth energy system. And then this energy works its way down. So that's what's happening right now. And it's happening in a very interesting way because of the fact that this geomagnetic storm has been fairly long duration now. So let's look at some of these conditions directly. And we can see these magnetic field swings as they're happening here with our geospace delta B map. Look at how strong some of these magnetic field swings are. This is 400 nanotesla. It even goes beyond that if the colors get really dark red, but it doesn't show it. For example, a really powerful geomagnetic storm can cause the magnetic field to swing 500 nanotesla, 1,000 nanotesla, 1,500 nanotesla. If it's really close to the polar regions, Earth's magnetic field strength from lowest to highest is about 22,000 nanotesla to 67,000 nanotesla. So we see that we had quite a lot of geomagnetic activity. This is about 3 hours that we're looking at here. Some periods where it's cooling off, but in general now, for 24 hours, we've had some significant geomagnetic activity. And we see it kind of starting to come back up again here at the very end. So that is where we are right now. And the solar wind is strengthening and may get back to these levels that we saw here just 3 hours ago. Let's check that out. We can go to our real-time solar wind. And what's so interesting about all this is that we have a blood moon coming up just in about 24 hours or so. A little bit more than 24 hours. Thursday night, Friday morning. And so when the moon moves through the magnetotail, a full moon, it can cause greater energy perturbations to the Earth. Now we have one that's going to be exactly along that Sun-Earth plane. It's going to be a total lunar eclipse, casting the moon into a blood red color, the shadow of the Earth. And we have this energy injection occurring right before that, perhaps even going all the way into that blood moon lunar eclipse. So there's going to be more energy there for the moon to work with and to kind of finagle, you could say. It's going to be really interesting to see how these sort of energies express themselves over the course of the next 36, 48, 72 hours or so. Here we see our solar wind. This is the past 3 days. We are in normal conditions back here. We see our plasma density, our velocity, our temperature. Here's our KP index, a measure of geomagnetic volatility. And it goes from 0 to 9. 9 is these really big swings in the magnetic field strength. That creates energy volatility on the planet in general. And when you have these swings in the magnetic field strength, you also generate these electric currents in different parts of the Earth energy system. The ionosphere, which is a weakly plasma charged part of the atmosphere close to like that space environment. Basically, it's the boundary between Earth's normal atmosphere and space. And then you also have these sort of electric currents generated in Earth's surface that we walk on and in the oceans and more. And so when you see this KP index go up, you know these electric currents are getting stronger and stronger. Now we can see the actual magnetic field characteristics of the solar wind right here. This is what's causing Earth's magnetic field to absorb this energy because of its special characteristics. Here we see the southward component is negative. What's that mean? Well, the magnetic field, any magnetic field can be measured in terms of vector directions, X, Y, and Z, right? X, Y, Z. It's arbitrary how we break that down, but you can do that. And so this is the Z component, that Z component. And when it's pointed this way, southward, and it's negative, then that connects really nicely to Earth's magnetic field, which is positive and pointing northward. And so you need this magnetic field typically to go down for Earth's field to connect to it. When you get that connection, all of a sudden you get this energy pushed into the plastosphere of our planet. That's what's happening here. We see the magnetic field in general, the total magnetic field, ramping up here, going all the way to about 12 or so, which is about 2 times more than normal. We've seen magnetic field shocks much higher from the solar wind. Back May 10th to the 12th of last year, 2024, this interplanetary magnetic field total strength went to 73 for that Mother's Day G5 geomagnetic storm. This is only 10 to 12, but look at how long duration this is. This is 24 hours already now, and it's almost completely defined by the southward component being negative, and pretty sharply negative too, also around 10 nanotesla, but in the negative direction. So we see here that we're getting this new bucket right there, and we'll see if this continues on. It does look like the magnetic field strength is starting to go back down again. We see our velocity has gone up a little bit, 550 kilometers per second there. Density is fairly high, getting close to 20 ions per cubic centimeter. But we just don't know how long that's going to continue to last. But so far, it's already been 24 hours. You see this KP index going up, and that's causing a massive amount of energy and information to be deposited into the Earth energy system. This happens to a greater degree during the equinoctial months. So basically March and April and September and October, around the equinoxes, you get this effect. And so you can have bigger geomagnetic storms and more Earth electrification from less solar impacts, you could say, smaller solar impacts during this moment in time. Now, I want you to look at the electron flux because I've been talking about that, how this value that we hit there was one of the highest values that we've had in a long time. Going back to February, we did hit this mid-February, but besides that, it had been like a year or more by the last time we hit an electron flux of 10 to the 4. Now, what is this? We're measuring very high energy electrons at geostationary orbit at 5.6 Earth radii. This is in the outer radiation belt. You have 2 different radiation belts. You have an inner one, which is proton dominant, and outer one, which is further away, which is electron dominant. That one goes from like 3 to 10 Earth radii. The proton one goes from like 1 to 3 Earth radii. And so you have electrons normally hanging out in that outer radiation belt. Here we're looking specifically at electrons that are greater than 2 mega electron volts. 1 electron volt is 1 electron volt. You have a kilo electron volt, which is 1,000 electron volts, and then you have a mega electron volt, which is 1,000,000 electron volts. So these are electrons that are extremely energetic, very, very, very energetic. And we see that we hit this very high value there. And these are called killer electrons in the space weather industry, because when you have them go above this alert threshold, they can cause deep dielectric charging to satellites, and that can cause there to be short circuits and failures and things that you don't want satellites to do if you're a satellite operator, right? Well, what's so interesting about this right now, we see that it ramped up really quickly from just back on like March 9th. Typically, when you have a geomagnetic storm, this drops out completely because it causes ion precipitation. I talked about how that electron storm was coming, right? So it'll drop really quickly to values like this. Well, look at this. We have 24 hours now of increasing geomagnetic activity now at a G1 level, but the electron flux is staying very high. It's staying elevated over that alert threshold. That is kind of crazy. Normally this would go down right away, and that may happen tomorrow, maybe. Depends on when the storm ends. Sometimes there can be a little bit of a delay to this. But the fact that it is taking the brunt of this geomagnetic storm and staying elevated is quite wild. And what you see after a geomagnetic storm is typically a rebound in the electrons. They get washed out and they precipitate down to Earth during the storm, and then they actually rebound afterwards. So the fact that we are here now, it's going to be really interesting to see what happens with this electron flux over the next day or two, because they could perhaps even go to even higher levels. And again, they're known as killer electrons. They cause these satellite problems. And if we get a very significant ion precipitation, that can cause a lot of electric charging of the Earth as well. So we have our outer radiation belt experiencing a lot of electrification at this moment in time. These are actual electrons, right? So this is not a misnomer to say the word electrification. This is electrons. As of this moment right now, because of what's happening with the solar wind and more. Now, we can look at our HB60 and our HB30 indices, also our KP index right here, to get a sense of this storm. This second shock wave that came in. Here we have our HB60 index. Here was that first solar shock wave that I talked about. Here's the second one. And so we see this one here, about the same duration, a little bit weaker than this first one, but the electron flux is a lot higher with this one, which is interesting. But we'll continue to see where this goes because it's still basically continuing on at this moment in time. Here we see these values. This storm here, this is back on March 9th or so. This had a KP value high of 5.667. Here it reached a value high of 5. So they're both G1 storms. And it's likely that this will continue to stay a G1 storm unless the solar wind strengthens dramatically over the next few hours, which is possible, but I'm not putting the biggest bets on that, you could say. I think we're seeing the maximum strength of this enhancement of the solar wind. Now I just want to show you this quickly because this is our Saturn Cazimi. This is our chronograph that we're looking at. This is the sun right there, denoted by this little white circle. They put an occluding disk over it so we can see the solar corona, the solar wind, outflows, etc. We also see the stars behind the sun and, well, the planets. That's Saturn right there, just having moved through a conjunction with the sun. So it's on the other side of the sun. And we have this blood moon coming up just about, again, 24, 36 hours or so. And Saturn will be on the other side of the sun. So you have a perfect alignment basically between the Saturn, sun, the Earth, and the moon. With the sun, Earth, moon all being on the exact same ecliptic plane, Saturn being to the south of it. So it's not on the ecliptic plane exactly, it is to the south as you see there. And it will be slightly off in terms of the angle as well, about 2 degrees off. But still very close to a perfect alignment between all of them, which is notable. And this blood moon coming up, again, because of this increasing electrification, is going to be having a lot more energy to work with. It's going to be very interesting to see what happens with that blood moon. This is just another additional energy modifier on top of that. I'm not saying that this is the biggest one ever, but it's just when you get lots of things combined together that things get really interesting. And that's why you have to kind of pay attention to all these different things, because if you miss, let's say, 2 or 3 additional little modifiers, but they add up, then you're not going to have the best forecast or picture as to what is happening or evolving. So this is another additional energy modifier. This went exact again, basically over the past 24 hours. So that specific individual energetic effect, you may have felt it then, but it's still contributing now and then all the way through this blood moon, which we have coming up. And let us look at that blood moon. Here we have our graphic here. This is all universal time. And so we have the moon passing behind the Earth. That's the full moon, right? It's going to be a full moon. We see that right there. It's a full moon, just like a normal full moon. And so the sun will set and then the moon will rise. You get a full moon. The timing of that is the sun will set, the moon will rise. They're in opposition to each other. So the moon will rise after the sun sets, but it will pass into Earth's shadow. First the penumbra and then the umbra. And when it gets 100% into the umbra, that's what turns it a blood red color. Check it out. Again, these times are universal times, so you can convert to your own location on the planet, because there's people from all around the world here who watch this channel. Hello and welcome everybody. But it turns a blood red color, and that phase of totality will last about an hour or so. So a pretty long phase of totality would last longer if it cut through more towards the middle there, but still we get about 1 hour of totality, and then we get some of this partial phase as well. Now the exact timing for this is Thursday the 13th through Friday the 14th, and that applies for if you're on the west coast of the United States, because that'll be 11:26 p.m. to on the 13th, Thursday night, to 12:31 a.m. on the 14th, Friday, early morning on the west coast of the United States. That's that phase of totality. If you are on the east coast, it's 2:26 to 3:31 a.m. on the 14th. Now, if you're Central Time, it's 1:26 a.m. to 2:31 a.m. on the 14th, early morning. And then if you're Mountain Time, it's 12:26 to 1:31 a.m. I would highly recommend you go out and give this blood moon a look when it happens. Just set your alarm. I know you'll be groggy. It's worth it though. Definitely go out and see that. If you're in Hawaii, you'll be seeing this more as a blood moon moonrise. So right as the full moon rises, it will turn blood red pretty quickly. And then if you're in New Zealand, same story. If you are, if you're in Europe, the far edge of Western Europe, Portugal, Spain, and even like parts of Western Africa will see this, or like Bermuda, perhaps, you know, the Caribbean, not the Caribbean, but Bermuda, those areas, east side of the Atlantic, you'll see this right at the very end of moon set, turn blood red right before the sun rises on the 14th. So yeah, we have a lot happening right now in terms of our space weather environment, and we also have a whole bunch of new activity rotating in. Let's give our sun a look. There has been some low-grade flaring activity over the past few hours, which has been interesting. So we can give that a look right here. Here we have our sun, and this is our 131 angstrom view. This is going all the way from the 10th to today, the 12th. And none of these flares are really worth writing home about, you could say. We've only had very low M-class activity and high C-class activity. But you'll notice just how much activity is rotating as compared to before. We've just had a lot of kind of emptiness here, though these were coronal holes, right? We do have some plasma filaments here. They could destabilize, we'll see. But look how bright things are getting. And this is a whole phase that we have coming up ahead of us. So all these guys here are going to be working their way across Earth facing for the next 10 days or so. And the ones on the limb will take 2 weeks to go through. We see some flares right there. These are M-class and C-class flares. But again, we got a whole lineup coming here that's going to really start playing with us after this blood moon. So this energy ramping is not over by any means. Now they could stay totally quiet. They could just stay calm, quiet, and nothing happens. We've seen that before. But just letting you know that there is a higher potential of something because we have more sunspots now. Sunspots are over 150 again. Solar flux, this is 2800 megahertz, is over 160. And there's just been, in general, more flares over the past 36 hours. I can show you that really quickly with our X-ray flux here. And we see that we've had more flares over the past 36 hours or so. So we see it really starting there with some, I think that's an M-class, and then there's a high C-class flare. But we see that sequence there. Look before though, 36 hours before that, nothing. But here, all of a sudden now we see that volatility coming in. Again, we're not really in that M-class zone yet, or even the X-class zone. So we are still in kind of quiet activity in general as compared to, let's say, a few months ago. But there has been a shift. There has been a shift in solar activity. We see that very clearly there with our X-ray flux. And that's likely to stay like this again for like the next week or more because of how these new active regions are rotating through Earth center direct. And they seem to be growing too. There's sunspots that have been on the disk that are growing. And so that is what's happening with the Earth right now, this Earth electrification, this 24-hour plus now geomagnetic storm. And that energy is all coming into the planet. It's all kind of being deposited into the plasmasphere. The electron belts, the radiation belts have been staying highly fluxed, you could say. And this energy is going into the ionosphere over time, creating these really powerful electric currents, which generates electric currents in the subsurface. We just had an earthquake swarm in Iceland near Grindavik, but more the southwestern peninsula near where like Blue Lagoon is in the airport. And so there may be a new burst of like volcanic activity out of Iceland. Kilauea has been erupting. This is like the 13th eruption it's had. It just started to settle down, but it's been erupting like big lava fountains. They've been getting bigger each time. Fuego, a volcano in Guatemala, had some incredible eruptions back on March 10th or so, March 9th, March 10th. That may continue to erupt. There's just in general a lot happening. And, I just want to touch on the fact that, for example, like Campi Flegrei in Italy, that we don't know what's going to happen there. But with these volcanic systems, we often see earthquakes, and then there's a delay of months before we see some sort of volcanism. That's perfectly illustrated with Iceland. Or like what's happening in Greece. We had that earthquake swarm. It's now cooled off. But that was a massive fracturing event. And that was one of, if not the biggest earthquake swarms that's ever been recorded in that part of the Aegean Sea in Greece in recorded history. Like since we've had seismic measurements. I can't say that definitively because there's a whole bunch of these swarms that have occurred, but based on the research I've read through, that's definitely the most notable and crazy kind of earthquake swarm that's existed there. And so if that is based on some sort of volcanic activity at depth, which there's quite a bit of evidence for, it can take time for these things to express. It's not like you have the earthquake swarm and then boom, you have a volcanic explosion or something. It takes some time. So, the Earth has a lot of ways of expressing herself. So just keep in mind that there's also some other systems around the globe that have shown a lot of activity that have cooled off a little bit now, but perhaps they will respond to these heightened energies that we have happening. We also have what's been happening out of Ethiopia with the two volcanoes there, Fontali and Dauphin, and the intrusion that's been occurring, the massive earthquakes that have been occurring along that 40-kilometer dike and more. So yeah, there's a lot that's been occurring. Even though solar activity has kind of cooled off in terms of like solar flares. But these coronal holes are strong, the high-speed streams are strong, we're absorbing a lot of energy from the solar wind at this moment in time, and there is an electrification that's occurring. It'd be really interesting to see how the blood moon plays with that. So that is it for today's update. Thank you all so much for watching. Again, I've been your host, Stefan Burns. If you'd like to stay appraised with what is happening, then please subscribe to the channel. I'll keep you up to date every step of the way, whether that is on YouTube or you can go to my Twitter X account at Stefan Burns Geo. I post interim updates there. I'll be doing that more because I will be on vacation for the next week, but it'll be easier to post to Twitter, just some little in-between updates. So I'll do that. And smash that like button, show your support, show some love. Sending you all lots of love and light. Wishing you all well. Please take care. I'll see you all very soon.